Welcome back to the workshop. Today we're going to play with these vacuum fluorescent displays. I got these on eBay. One thing I can tell is I think if they go bad, this little dark spot here, so this one's good and this one's bad. It turns white. I've also blown the filaments out in another one that I had, so you have to be careful of how much voltage and current you apply to the filaments. Reading online, it suggests 3.3 volts and then using a current limiting resistor of some type. What I did was I used the lab benchtop power supply to give it 3.3 volts. And then I also used a variable resistor, and I'd turn it up until I could just barely see the filament glowing red without any lights on. So that's how I determined the value of the current limiting resistor to use. And I'm guessing it depends on what vacuum fluorescent display you have. I forget what the value of this resistor is. Really quickly. So it looks like it's 85, probably 90 ohms. So given that, basically we need, oh yeah, I remember now. I basically use the variable resistor with the 5 volt rail. So it's not quite with 3.3 volts, but it seemed to work okay. Okay, so the next component that's required is a step-up converter. This one's pretty nice because it has a USB interface into it, or you can supply positive 5 volts there, and then it steps the voltage up. These VFDs online, they say that they require anywhere from 12 volts to 30 volts. I've adjusted this one to be outputting 27 volts or so. So we'll be using our Arduino to get power. And then for the VFD to operate correctly, the grounds need to be shared between the 5 voltage side and the high 30 volt side. Okay, let's see if the stepped up voltage is coming up. Yep, 27.11 volts. So this pin on this side is grounded, and then this pin is going to the positive 5 volt rail through a current limiting resistor. And then if you look at these VFD things, you see that there's these grid meshes over each digit. And like, for example, here's one, here's one, here's one. They kind of follow a pattern. And then the remaining pins, they go to the segments of the digits, and they're all wired in parallel. So to run these displays, you need to do some multiplexing to quickly switch between them so that the user cannot see with their own eye. So if we choose 2 of them to light up, that one didn't light up. Okay, yeah, so there's a segment that's lighting up. You can see it in there. These are nice displays. I like how they look. I salvaged this one from an old calculator. This is going to look really nice when I get this one to work. I really hope that the filaments are still intact in it. I can't remember if trying to get this to work if I blew them out. I can see them in there, so I think it's still good. Okay, so we have to drive these inputs here with a higher voltage. And in order to interface with the logic level, we can use transistors to do this. And the idea will be that they'll all be wired through current limiting resistors um, to high voltage, and then when the transistor is applied power, it'll pull them down. That'll be more clear in a little bit. What we're going to do next is make this rail here the high voltage side, and then we'll put in an array of transistors in here to allow us to control the high voltage outputs with digital logic. See, I forget what these transistors are. They're S9013 common transistor. And then these will be going to the high voltage line. So all the pins are initially, if the transistors are not turned on, are going to get high voltage. So to turn off a line, we turn the transistor on. So it's a little bit opposite, but that's okay. There's a lot of that going on in electronics. I forget what the value of this resistor is, and these were cheapy resistors, so the values that they read are not accurate to what they were listed at. This one's good, it's 10K. Also, the colors on them are horrible. Like they don't look like the colors that they say they are to me. One thing I like to do is make these Lego pieces here. So you can see that I soldered the transistor onto these pin headers. And that just makes it, I think, neater, and I enjoy soldering the different parts on them. I think that's it. There should be 17 of them. Okay. Now let's connect the transistors to the input pins on the VFD. Let's add another rail so it's easier to ground the transistors. And then also the transistors are going to need current limiting resistors on their bases. Also, if we had the ability to tell the state of the transistor, it'll help for debugging. So let's add these LEDs here, which will show us the state. I feel like somebody on the assembly line. Cool. Now finish grounding the transistors. Okay. Okay, let's put this high voltage power supply in here. So this right here is going to be our high voltage line. We already have a common ground there. We probably should ground this here so it's common too. And then we'll make this down here our normal voltage line for 5 volts. And let's see how to do this here. We got VNs there. And then see the ground's there, so let's make ground. positive. And I've already checked the two ground pins here are shared, so we don't have to worry about that. So then we just need positive voltage there. That's good. And then let's put down another board down here so that we can get power to it easier. I appear to be clumsy today. Okay, this one here should be positive volts. Right down below K, and then K should be negative volts. And those are lighting up, which is correct, but nothing on the display. Oh, that's right, we need positive volts there too. I can hear the fan on my laptop. That's making a lot of noise. Well, it's got voltage. There we go. So those are on right there, and you can see that. Not quite sure if you can see that. It might not be in focus. Seems to be as good as I can get it focused. But that's working. So most of these pins are in a floating state, so they don't really have like a true or false value. And see, there's another one there. So this is working. So now we have to hook up some shift registers so that we can do the multiplexing to get the digits to light up how we want. Cool. Okay, so here's these 74595 shift registers, and we're going to put them upside down so the electrons fall out. It's easier to wire them up that way. So let's see. And then let's take care of the power, VCC. And I'm now seeing that when I did this before, I've already bent these, so I screwed up and I gotta put another rail on. I was wondering why I had to cut that. I was trying to make myself look really slick, putting all this together, like there's some magic behind it. I won't tell if you won't. I was wondering why it seemed different. Okay, there we go. Something's not getting power. All right, okay, the ground. Didn't like that at all. Okay, what's going on here? Oh, no. Don't short the Arduino. Okay, everything should have power. Oh, there we go. Nice. Okay, so now we can continue wiring up the shift registers. We go and look at the data sheet. So VCC is down here on these guys. Now we can take care of the grounds. Cool. Then we have a couple things that we need to tie high and low. See, the output enable needs to be tied low, which is the fourth one down. Then we have second from the last pin, which is SRCL. So reset clear, so that has to be tied high. Okay, I believe that's it for the basic things. So we're going to be shifting the bits into this one and they'll propagate that way. So on one of these, it's hard to see from my diagram or the picture I took of when I already did this. So looks like we have one that's on the last one and it goes into the third one. There's the last one. The last one is carryover, QH prime. And then looks like we have a green one, which is on the third from last. And that one's going into the fifth one.
1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Yeah. Quite lining up. Which one is that? It's probably going to be clock or something. Third from last, yeah. Oh, yeah, it wasn't reading. Okay.
That. You can look up online Arduino shift registers, and there's a very good tutorial from which I learned this stuff from. Okay, so then the greens and yellows are basically carrying the signals all the way through. And then we have the carry out bit, which goes into the third one like so. So hopefully all that's correct. If not, we'll have some debugging to do. So let's wire up the first one. And the next one. So this one here is only using 1 bit. It's kind of wasteful. I tried to use in the past the carry out here for that, but unfortunately it doesn't quite work because the timing is off by 1. So I can light up 2 of the lights at the same time, but doing a test of shifting a single bit all the way through, it wouldn't work. Or I couldn't figure out how to get it to work. And you can tell those are being set low as I'm connecting the wires up. Nice. Thanks for watching. Stay tuned for more on this project. Remember, keep on tinkering. Please like the video, subscribe, and comment as you may.